So let's try and understand what happens with limits that we need to calculate. And let's try and come up with techniques to calculate infinite limits and limits at infinity without having to plug in x values into a calculator every single time. So let's first see what happens with this one limit, 2 minus 5x over x minus 3 when x approaches 3 from the right. Immediately you can see that the bottom of this limit is going to be 0 because x is going to be very, very close to 3, but bigger than 3. So if we wanted to plug some values in, we could do 2 minus 5. So x needs to be bigger than 3, so like 3.1 works, divided by 3.1 minus 3. So we would get something like this. Now if we maybe used 3.01 instead, that would also work. And we should get closer to the limit as soon as my calculator allows it. There you go. You either get something in the thousands now. If you do this again, you get something again in the tens of thousands. So the result's getting bigger and bigger, but it's keeping its negative sign. So this means that we would expect that this limit is minus infinity. So how can we come up with a way to reach this conclusion without having to plug in successive values into our calculator? This is how we can think about it. We can think about it by noticing, first of all, that the bottom will be very, very close to 0. So it would be very, very small. So we would have I'll start writing the limit now. But we're going to have 2 minus 5 times 3. So whether this is 3 or 3.1 doesn't matter at the top, I'll say. But the bottom, because we're near 0, that matters because something close to 0 could be positive or negative, and that changes our result. So we're going to have something very small, but because 3.1, right, x is more than 3, x minus 3 is going to be positive, right? We can write that here. X is bigger than 3, that means x minus 3 is positive. So this positive goes from here. So we're going to have a 2 minus a 15, so a minus 13, divided by something very small. And like I said, right, the small comes from the fact that x is, let's say, if I go to the bottom there, 3.0001 minus 3, that's very, very small, but still positive, right? So that's my small there. So now I'm asking, is the answer of this going to be big or small? And we can think of it in terms of what the division operation means. We're asking, how many small things fit into 13, right? How many small things can I add before I reach 13? So that's going to be a lot of them because the things are small. So that's going to be big. The answer is going to be big, but now minus with plus give me a minus. The answer is going to be negative. So that means that the limit when x approaches 3 from the right is going to be of 2 minus 5x, x minus 3 is going to be minus infinity. So that will be my answer. Now, if I apply the same reasoning to b, let's work on b before plugging in things into the calculator now. Now we're going to have, so this will be approximately 2 minus 5 times 3 over, and now I have, split this. So I'll do 2 minus 5 times 3 divided by, so note that now x is less than 3 because x is approaching 3 from the left. So x minus 3 is less than 0, which means it's negative, but still very small. Right? So it's like I was doing 2 minus 2.9999 or something minus 3, right? It's very small still, but now it holds a negative sign, so it's minus something small. So that's a minus 13 over minus something small. How many small things fit into 13? A lot of them, so the answer is big. But now minus with minus is plus, so this means that the limit of x, as x approaches 3 from the left, 2 minus 5x equal to, over x minus 3 equal to plus infinity. And that will be my answer. This is my symbol there. This infinity symbol is just an 8 sideways. Sometimes my handwriting is not going to be the best, but that's the symbol. So I think this is a clever way to justify your answers for these limits. Let's work on C now. On C we're going to do this. So first we're going to have to factor. So this will be the limit. X approaches 4 from the right. Pull out an x from the top to get minus x squared plus 5x minus 6. And then I'm going to get x squared from the bottom, x minus 4. Let me check if I don't have any typos on this top, because what I want, I don't think it actually matters whether I have a typo or not, because this is my problem, right? I could factor this, divide these two. X is not 0, right? Because x is close to 4. So x is not 0, which means I can divide by x and simplify it. So this is x approaching 4 from the right, minus x squared plus 5x minus 6 over x times x minus 4. Now let's be careful and think about things again. What will the top be and what will the bottom be? So we're going to do this. Plug in the top, 4, so that's going to be approximately minus 4 squared plus 5 times 4 minus 6. We've got to be careful that this is not 0, because if it is, then we are going to have some trouble. And is that going to be 0? So that's a minus 16. That's not going to be a 0. Cool, so we're good on that. The bottom will be 4 times, and then x minus 4 will be very small because x is approximately 4, but x is bigger than 4. So this is going to be something positive small, right? Something positive small. So what we'll get here, minus a 16 plus 20 minus 6. 4 times something small is still small, like 0.001. I just think about it that way, like 0.001. If I multiply that by 4, that's still pretty small, right? The answer then will be, so positive still, right? Because 4 times a positive is positive. And then I have minus a 22 plus 20, that's minus 2 over plus something small. So the answer is going to be negative something really big. So the answer for us is going to be minus infinity. Space wasn't great, but the reasoning still works. Take a second to understand. Split screen again. Not split screen, split the space that I have. Okay, let's see what happens. Now these are different limits. Maybe I'll use a different color for those. These are now limits at infinity. But we can reason more or less in the same way. Here's what's going to happen for D. Now x is getting big, so x is becoming bigger and bigger with a positive sign. It's going to plus infinity. There's no plus here, but whenever there's no plus, we mean the number is positive. So let me go green on that. So this will be 2 divided by something big minus 3, because x is very big but positive. And again, something big divided by subtracted 3 from it doesn't change much. Like if I do, what's that, 100,000 minus 3, that's still pretty big, right? 99 1,997. That's still big. So that is 2 divided by something big and still positive. So how many of something big fit into 2? Not much. So the answer is going to be small and positive. So just think about it that way. If you divide 2 by something really, really big, the answer is going to be really, really small. And the sign is going to be positive. So this limit, x goes to infinity, 2 over x minus 3 is 0. And that's what I mean by small. Small is something that's close to 0. Big is something that's far away from 0, either positive or negative. Now E is going to have a surprise for us. And we're going to try and apply this reasoning on E, and you're going to see what's going to happen. Here's how we can try and think of E. I'll do this one in red because you're going to see that this won't quite work. Let's see, let's plug in, let's think about what happens when x is very, very large and positive. So we have 2 minus 5 times something big and positive. Remember that we have to keep track of whether the big thing is positive or negative. Plus something big, minus 3. So 5 times something big is still big, but then we get a negative sign. So 2 minus something big minus 3. So that's minus something big divided by something big. And what do we do now, right? We don't know whether the two big things are equal or not. And that's our problem. So we are in kind of a pickle there. If the two things were equal, we could cancel them out to get a -1. But we don't know if they're equal. In fact, they're probably not equal. So how do we do that? Here's the way to reason through. So I'll erase this so we can start over. We're going to look at the two top and bottom of the fraction. We're going to look at the highest exponent that we have. They're both x to the first, and then we're going to divide both top and bottom by x. X is not 0, so we're allowed to do that. And now I'll change back to, let's say, purple, so you see the difference. And then I'll do the limit. X goes to infinity. Dividing by x. Divided by x. Nothing changed because I divided by x on both the top and at the bottom. So I can do 2 over x minus 5, right? Because 5x divided by x, just cancel the x's, I get a 5. And bottom, 1 divided by x is 1 minus 3 over x. So what happens now? X is getting very, very big. So 2 divided by something very, very big is going to be 0. 3 divided by something very, very big is going to be very, very small, so 0. So this will be 0 minus 5 over 1 minus 0. So that's just minus 5. Okay, so I was able to find my answer. See, it was not 1. We were wrong before. And in fact, if you want to check your work with a calculator to see that you're getting numbers that are closer and closer to 5, let's say plug in x equals 1,000 to C. So I would do 2 minus 5 times 1,000 divided by 1,000. You can already see, right? Minus 3. See? Very, very close to -5. And if I add more zeros to my x value, I'll get even closer to -5. So it does make sense that my limit is -5. That was the trick. To instead of be handling big numbers, I was just handling 1 over big numbers, right? Divide by the biggest of numbers that I was able to find. Okay, how do we apply this idea to f? On f, I can look at and see that this will be, look at the highest degree. This is x squared. So I'll divide by x squared in both top and bottom. So I'll do 2 over x squared. I'll skip a couple steps now. So minus 5 over x squared. Cancel the x squareds out. So x over x squared is 1 over x. Minus 3 over x squared, excuse me. So let me actually do this again, because maybe I skipped a beat and maybe that was difficult for you. So let me maybe be careful about that. So that will be limit x goes to plus infinity. So 2 over x squared minus 5, and bottom is 1 over x, right, because we're dividing these. And then minus 3 over x squared. So now I don't have a clear number that I get because, well, this is going to be about a negative 5 on the top, but then the bottom will be about a 0. Right, so I gotta look at what happens. This is going to be 0 minus 0, so it's going to be about a 0. But is this positive or negative? I don't know. This is kind of more difficult to see. Much more difficult to see. So instead of dividing by x squared this time, I could decide to divide by x to avoid having that 0 at the bottom. So I'll start over. Instead of dividing by x squared, I'll divide by x. So I'll do 2 minus 5x squared over x minus 3 over x. So that's the limit. X goes to infinity. So now I can get 2 over x and then minus 5x. And that will be 1 minus 3 over x. So what will that be? I'm going to get about a 0 because x is getting very, very small, so I'll get about a 0 there. Minus 5 times something positive and big, so that's big, over 1 minus something small, right? Minus something very small, so that's just about 1. So since the answer there, something very, very big, negative divided by 1, then I expect that the limit x goes to infinity, 2 minus 5x squared over x minus 3 to be minus infinity. That's my answer. Now there are two interesting things happening here. The way to think about f is to note that, okay, the degrees now are different. So because the degree of the top is bigger, then this x squared is big, and this x, even though it's big, it's not big enough. Right? So if you just compare the two things, let's say when x is 1,000, then 5 times 1,000 squared is this. What's that? 1, 2, that's 5 million. And what about just 1,000 at the bottom minus 3? That's 1,000. So even though the bottom is still big, the top is way bigger because it's squared the big number. So the answer is getting bigger. You're dividing something big, but something at the bottom that's still big but not big enough. So the result is still big. Okay, that just happens always when the power of the top is bigger than the power at the bottom and x is approaching plus infinity, and then you just got to check the sign, right? Because this is negative and this is positive. So the answer is going to be a positive. If you look at the top now, you're going to have something like minus 5. At E, I'm talking about now. At E, item E, you have something big times 5 and something big. So they're both big, and that they're big at the same order. The powers are the same. So that means the two big things kind of cancel. The top will be in the thousands. If I plug in x equals 1,000, the bottom will also be in the thousands. So we're going to have about the x is sort of canceling out, and the answer being 5, minus 5. You always think about it that way. So kind of matching the leading coefficients. Minus 5 over 1. So let's try and think about it that way for G. And I'll end there. So on G, X is getting very, very, very negative, so all that matters, negative and very, very big, all that matters is this, because all the rest here is still going to be big, but not big enough to matter. And at the bottom, the biggest portion is x cubed. So this is about the same as the limit when x goes to minus infinity of x cubed, x to the fourth over x cubed. So it's about the limit x goes to minus infinity of x dividing both. So that's just minus infinity. Now actually replace all of these approximation symbols by just equal signs, because this is a fair argument. We're just looking at the bigger numbers there, the ones that matter most. So this same thing happens here. X goes to minus infinity when x cubed is the highest degree of the top and x cubed is the highest degree of the bottom. So that's just the limit. Two equal things dividing each other. That's just a 1. So the answer for this is just 1. So that makes it very, very easy and simple for me to make those calculations. I hope this helped you understand infinite limits and limits at infinity a little bit.